Okay, so now that we've had practice working on finding sums and differences of special angles to make up these non-special angles, now we're going to use part of that skill and actually find the sines and cosines of such sums or differences. So here we got sine of 5 pi by 2. Hopefully that angle looks familiar to you. The important thing here is to really concentrate to find which two special angles will add up or even subtract to make the angle that's given here. Okay, so we see our formula for sine. Suppose we've got sine A plus B is sine A cos B plus cos A sine B, and we then need to find two angles A and B that will add up together to give you 5 pi by 12. Okay, so think about that for a few seconds, and then you can come back and check the answer here. Okay, so please make sure you pause the video and find which two angles will add together to give you 5 pi by 12. Okay, so from the previous example we knew that pi by 4 and pi by 6 with a common denominator of 12 will add together to give you 5 pi by 12. So then sine of 5 pi by 12 equals the sine of pi by 4, cos pi by 6 plus cos pi by 4 times sine of pi by 6. Then use the special triangles to calculate each of these sine and cos ratios in exact values. So what's sine of pi by 4? 1 over root 2, cos of pi by 6, and then cos of pi by 4, sine of pi by 6. Okay, if you didn't know these that quickly, make sure you review the special triangles and really think hard on doing these before you watch the rest of the examples. Okay, so now we're just going to multiply here. So we've got root 3 over 2 root 2 plus 1 over 2 root 2, which can simplify to root 3 plus 1 over 2 root 2. And then if we want to rationalize the denominator, we'd multiply top and bottom by root 2. So we get root 2 times root 3 plus 1 all over 2 root 2 root 2. And then if we multiply this in, we get root 6 plus root 2. I guess you could have left the numerator in the factored form if you like. And root 2 times root 2 is the root of 4, and the root of 4 is 2, and then 2 times 2, root 2 times root 2 is root 4, and root of 4 is 2, and then 2 times 2 is just 4. Okay, and that can sometimes be seen as 1 over 4 root 6 plus root 2, like that. Okay. This next one, when we're looking at cos of 23 pi by 12, that's a lot more challenging to find the exact values, or the special angles to see what adds up to that. So what I suggest is perhaps break this down into, say, 1 pi by 12 plus 22 pi by 12 and simplify, and then try 2 pi by 12 plus 21 pi by 12 and simplify, and see what you get so that you can find which angles will add together to give you 23 pi by 12. Then you can simplify those special angles, and then you have to put them on a Cartesian plane and apply the cast rule and the beta angle like we've done in the past, so that we can find what these the cos of 23 pi by 12 is. Okay, so please pause the video and work that out yourself right now, because if you wait around until I tell you the answer, then you're not actually doing much critical thinking on this, and then when it comes to quiz or test time, you won't know how to do it. Okay, so pause the video now please and work this out. Okay, so one of the options, and there are a few, I've got 14 pi by 12 plus 9 pi by 12, and that reduces down to 7 pi by 6 plus 3 pi by 4. Okay, so like I said, there are other combinations, but this is just one that I've chosen. So 7 pi by 6, that's going to be over here. So this is pi by 6 here, or sorry, 7 pi by 6. That means that the beta angle is pi by 6. And then of course we use the cast rule. And then for 3 pi by 4, we know it's over here. So that's 3 pi by 4. And beta angle is pi by 4. Again, apply the cast rule. And then from there we can just work this out. So because we're using a sum, cos of a plus b equals cos a cos b minus sine a sine b, which is cos of 7 pi by 6 cos of 3 pi by 4 minus sine of 7 pi by 6 sine of 3 pi by 4. And cos of 7 pi by 6 is the same as cos of pi by 6 with the added negative, because the terminal arm is in the quadrant where only tan is positive, therefore cos is negative. So that would be negative root 3 over 2. Cos of 3 pi by 4 is the same as cos of pi by 4, but again, it's in the second quadrant where only sine is positive, therefore this would be negative. And then sine of 7 pi by 6, again, the sine of pi by 6 with the negative sign. And sine of 3 pi by 4 is the same as sine of pi by 4, and it's in the second quadrant where sine is positive, so that just stays as it is there. Then we just multiply these together, so we got root 3 over 2 root 2 minus, we multiply those, we got negative 1 over 2 root 2, which gives us root 3 plus 1 over 2 root 2. Again, if we like to rationalize this, multiply top and bottom by root 2. So we get root 6 plus root 2 all over 4, which can be seen as 1 over 4 root 6 plus root 2. Isn't that interesting? These two answers happen to be the same, where we're looking for the sine of 5 pi by 12 and the cosine of 23 pi by 12. Interesting. Okay, on to the next couple examples here. So we're given that if sine of x equals 4 over 5 and sine of y equals negative 12 over 13, where x is between 0 and pi by 2, and y is between 3 pi by 2 and 2 pi, we need to evaluate the tan of x plus y. Okay, so the sine of x equals 4 over 5, where would that go? Keeping in mind this stipulation here. Okay, so the angle is going to be in here. I suppose I should be using a ruler for good mathematical form. And so here's the angle x, opposite over hypotenuse, and that's a traditional 3, 4, 5 triangle, so we know that base is 3 there. So we know that tan x is opposite over adjacent, which is 4 over 3. Then for sine y being negative 12 over 13, we know that y is between 3 pi by 2 and 2 pi. Where would that terminal arm be placed? Exactly, in the fourth quadrant, something like this. And haven't really drawn it all that well. This is y here, opposite over hypotenuse. Again, a classic triangle, which is the 5, 12, 13 triangle. So the tan of y is negative 12 over 5. And now from here we need to evaluate tan of x plus y. So the formula for tan of x plus y equals the tan of x plus the tan of y over 1 minus, slight error there, minus tan x tan y. Now we just plug in all the values and simplify. Okay, so please work this out the rest of the way yourself, and then come back to the video and check to make sure that you are correct. Okay, so then we're going to get common denominator of 20 over 15 plus 36, negative 36 over 15 over 1 plus, and we just multiply that straight across, 48 over 15. And then we're going to have negative 16 over 15 over 63 over 15. And when we divide, we flip and multiply. So we get negative 16 over 63. So that is what tan of x plus y equals. Okay, so here's your work for today. Please work on the first few at home, and then come in and work on the rest of them in class tomorrow. Okay, so thank you for your attention, and we'll see you in class.